Assalamualaikum and very good morning to everyone who's watching. So today I'm going to talk about application of Archimedes principle for submarine. So before we start, let me tell you about Archimedes. So who is Archimedes? Archimedes of Syracuse was a great mathematician, physicist, engineer, inventor, and astronomer. He is considered to be the greatest mathematician of ancient history and one of the greatest of all time. He is known for Archimedes' principle, Archimedes' screw, statics, hydrostatic, law of the lever, and indivisible. So today we are going to talk about Archimedes' principle. So Archimedes' principle states that the upward buoyant force that is exerted on a body immersed in fluid, whether fully or partially, is equal to the weight of the fluid that the body displaces. Here's the formula for Archimedes' principle. So buoyant force is equals to PGV, where P is density of fluid, G is the acceleration due to gravity, and V represent the volume of the displaced fluid. Okay, next. Submarine can sail on the surface or underneath it. Its outer hull is entirely watertight. Inside the hull are tanks called ballast tank. If the ballast tank is empty, the upthrust is equal to weight, so the submarine will float. While if the ballast tank is full, the upthrust is smaller than weight, so the submarine will sink. So this is a cross section of submarine. This one is a periscope. Valve. Here ada lubang kat bawah ni so that air ni boleh flow keluar. This is ballast tank and yang colour dark grey ni adalah hull. So there are in between two hulls that can be filled with either air or water. So ni lah space dia. And the ballast tank can give a sub control over its buoyancy. So next, there are two types of tank in a submarine, which is the first one is a ballast tank yang depan ni, and dua lagi yang kat belakang ni a trim tank. So ballast tank is used to move the ship up and down. So if the tank filled with air, the submarine is lighter than the surrounding water, so it will float on the surface. While when the ballast tank is filled with water, the submarine will be heavier than the surrounding water, so it will sink. So the main ballast tank has hole on the bottom and valve on top. This one. So if we want the sub to rise, we need to replace the water here with air so that submarine will rise upwards. So these two pula, normally the trim tank are positioned at the front and at the back of the submarine. Okay, let's assume that the front part of the submarine is heavier than its back. Macam ni. Yang ni lagi heavy daripada yang belakang ni. So the water from here can be pumped into the tank at the back so that submarine ni akan jadi balance. So this picture is about to explain how the submarine will sink and float. So the first picture, when a submarine is floating on the ocean surface, its ballast tank are filled mostly with air. Kandungan air dia lagi banyak daripada water, so sebab tu dia float. Because when it filled with air, the submarine rises to the surface because it has a positive buoyancy. Okay, the second picture pula, vent hole yang dekat sini on the ballast tank are open to allow the submarine to dive. So bila valve kat sini terbuka, air akan masuk ke dalam. So the air escape as the tank is filled with water. So bila ada water kat dalam ni, the weight of the submarine increase. Hence, the weight of the submarine is greater than buoyant force. So there is net downward force. Therefore, the submarine will sink deeper into the ocean. Okay, the last picture is show bila submarine nak float balik. So the vent hole are closed and compressed air is pumped into the ballast tank to force the water out. Dua valve kat sini close and compressed air daripada sini akan pump ke dalam ni so that air ni akan keluar daripada hole kat bawah ni. So the weight of the submarine is smaller than its upthrust. There is net upward force, so the submarine will move upward. Therefore, submarine will float when the weight of the submarine is equal to its upthrust. So next, one of the characteristic of submarine. Okay, it is a pressure hull. Okay, even with scuba tank, we can dive only so far because the immense pressure soon make it impossible to breathe. At the depth of 600 meters, the maximum depth subs ever dive to, the water pressure is over 60 times greater than it is at the surface. So, submarine akan ada dua hull, which is the outer and the inner one. So, hull of standard ship is the metal outside that keeps the water out. So the outer hull yang kat luar ni, external hull ni is a waterproof. While inner one, we call it as pressure hull, is much stronger and resistant to immense water pressure. So biasanya the strongest submarine have hull that made up from titanium or steel. So sebab tu submarine boleh pergi dekat depth lagi dalam daripada bila kita guna scuba tank. So that is all from me. Thank you.